Before we dive into the announcement, it's important to understand what particle accelerators are. The Large Hadron Collider, LHC, operated by CERN, is a 17-meter ring of superconducting magnets and the world's largest and most powerful particle accelerator. It represents the pinnacle of human scientific achievement. In fact, it's so powerful that it can recreate the very conditions of the universe's birth. But could this machine, designed to unlock the secret of the universe, hold the key to something far more ominous? CERN, founded in 1954, is one of the world's most prestigious research organizations, with 23 member states and thousands of scientists. It's a hub for collaboration and innovation. The LHC is CERN's flagship project, but it's just one part of a vast network of accelerators and experiments. Imagine a racetrack not for cars or horses, but for subatomic particles in a race against time and space itself. The LHC accelerates protons to nearly the speed of light, sending them on a collision course that mimics the energy of the universe at the time of the Big Bang. The collisions create temperatures 1,000,000 times hotter than the core of the sun. Thousands of magnets guide the protons on their journey, while intricate cooling systems keep the magnets at temperatures colder than outer space. The beams inside the LHC are made to collide at 4 locations around the accelerator ring, corresponding to the positions of 4 particle detectors: Atlas, CMS, ALICE, and LHCb. Each serves a unique purpose, exploring different aspects of particle physics. Together, they act as colossal cameras capturing snapshots of these collisions. Scientists then sift through the debris looking for signs of the elusive Higgs boson, also known as the God particle, and other phenomena that offer clues to the universe's fundamental building blocks. By studying the microcosm, we gain insights into the macrocosm. But with every answer comes a new question, and with every discovery, a new challenge. The LHC is not just a scientific instrument. It's a testament to human curiosity and innovation. It embodies our relentless pursuit of knowledge and our desire to understand the fundamental forces that shape our universe. Yet, as we push the boundaries of what we know, we must also consider the ethical and existential questions that arise. What are the risks of probing the unknown? Could our quest for understanding inadvertently unlock forces we cannot control? In the hallowed halls of CERN, where the boundaries of human understanding are constantly pushed, a revelation has emerged that sends a shiver down the spine of even the most seasoned scientists. Brian Cox, a former researcher at CERN and a voice of authority in the world of particle physics, has recently made an announcement that has left the world both fascinated and fearful. Cox's words resonate with haunting clarity. The goal of CERN's Large Hadron Collider is to recreate a mini Big Bang. Yes, you heard that right, a miniature version of the very event that gave birth to our universe. The physicist also went on to explain the implications of this goal, highlighting the LHC's extraordinary potential for making new discoveries. This includes its ability to unlock the secrets of the Higgs boson and explore dark matter, a mysterious substance that makes up a significant portion of the universe. Imagine holding the power of creation in your hands, the ability to conjure the very essence of the universe. It's a tantalizing prospect, but one fraught with danger. The mini Big Bang is not just a theoretical concept. It's a tangible reality within the LHC. The temperatures, the pressures, the raw energy, these all mimic the conditions of the universe's infancy. It's like standing at the dawn of time, witnessing the birth of existence itself. But with such power comes responsibility, and the question looms, what if something goes wrong? In fact, something did go terribly wrong back in 1978. The Russian physicist Anat Borsky experienced a disaster that would forever alter the course of his life. While working on the U-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia, a malfunction led to his head accidentally coming into the direct path of a proton beam. The beam, with a force that defies comprehension, passed through his skull, entering the back of his head and exiting through his nose. Borsky's experience was otherworldly. He saw a flash brighter than 1,000 suns but felt no pain. The beam's path left a trail of destruction, burning through tissue and bone. Yet, he remained conscious and even walked to the clinic for treatment. The aftermath was both horrifying and fascinating. The beam's path caused localized tissue death, leading to the loss of hearing in one ear and partial facial paralysis. Yet, astonishingly, Borsky's intellectual capabilities remained intact, and he continued his scientific career. This incident is not just a personal tragedy, but a cautionary tale that underscores the immense power and potential danger of particle accelerators. The risks of a particle accelerator like the LHC are not to be taken lightly. The potential for unforeseen reactions, the very fabric of space and time being manipulated, these are not the stuff of science fiction, but real concerns voiced by some in the scientific community. One of the most alarming and captivating concerns associated with the LHC's experiments is the possibility of creating a miniature black hole. Black holes are regions of space-time where gravity is so strong that not even light can escape. They are cosmic vacuum cleaners, devourers of stars, enigmatic entities that lurk in the shadows of our universe. The idea that the LHC could create such an entity, even on a microscopic scale, is shocking to both the general public and experts alike. Could this black hole grow uncontrollably, swallowing the Earth from within? Though scientists at CERN have assured that any black hole created would be unstable and evaporate almost instantly, the mere possibility has ignited debates, fears, and a sense of awe at the power we wield. It's important to understand how the LHC could create a black hole. It has to do with the fundamental mechanics of particle accelerators. When protons are smashed together at nearly the speed of light, the energy released is so immense that it warps the fabric of spacetime itself. Imagine a trampoline stretched tight, and then a heavy weight is dropped onto it. The fabric bends and curves, and if the weight is heavy enough, it could create a depression so deep that anything nearby would be drawn into it. That's a simplistic metaphor for what could happen in the LHC. In the world of quantum physics, where the rules of the universe are both bizarre and beautiful, there exists a theory that extra dimensions may be hidden within our reality. If these dimensions exist, the LHC's collisions could tap into them, creating a gravitational funnel that forms a microscopic black hole. This enigmatic dance of particles has even caught the attention of some world-famous scientists, particularly the late Stephen Hawking. In his book, he warned of a scenario where the Higgs boson could become unstable at very high energy levels. This instability could lead to a catastrophic vacuum decay, a cosmic event that would not only destroy the Earth but the entire universe itself. The esteemed British cosmologist and astrophysicist Sir Martin Rees also expressed his concerns about the experiments conducted at CERN. In his book on the future prospects for humanity, he explored the potential risks associated with particle accelerator experiments, including those at CERN. His words were not merely cautionary. They were tinged with a sense of existential dread. He spoke of a worst-case scenario where an ill-fated experiment could create a condition called vacuum instability. This instability could, in theory, trigger a phase transition that would ripple through the very fabric of space-time, resulting in a cosmic catastrophe that could engulf the entire universe. Rees's concerns were not limited to theoretical musings. He assigned a probability to these catastrophic outcomes, albeit a low one, but even a minuscule chance, he argued, should give us pause. The stakes are unimaginably high, and the margin for error is razor-thin. The scientists at CERN have calculated the probabilities, run the simulations, and examined the theories to argue for the safety of the LHC. In fact, Brian Cox himself acknowledged the importance of responsible exploration, recognizing that there are widespread fears and concerns surrounding the activities of the LHC. He emphasized that there are rigorous safety measures in place, extensive reviews and protocols that ensure the LHC's operations are conducted with the utmost care. Cox reassured that the energies involved are well within what the Earth naturally encounters, and the chances of creating a stable black hole are astronomically low. Even if one were created, scientists say it would be so tiny and so unstable that it would evaporate in a flash of energy, a phenomenon predicted by Stephen Hawking, known as Hawking radiation. It would be a fleeting moment of cosmic wonder, a glimpse into the abyss and then gone. Some have gone further, speculating that the LHC's experiments could open a portal to another universe or dimension. This notion, though largely dismissed by the scientific community, has captured the imagination of many and has become a subject of fascination, fear, and even folklore. What lies beyond our reality? Could we inadvertently unleash forces or entities that we do not understand? The idea of opening a portal to hell has even been sensationalized in various media, adding fuel to the fire of uncertainty. But how did this idea come to be, and what does it mean in the context of scientific exploration? The concept of parallel dimensions is not new in physics. String theory, a leading candidate for a unified theory of everything, posits that there may be more than the familiar three dimensions of space and one of time. These extra dimensions could be compactified or hidden from our perception, but they could theoretically be accessed or revealed under extreme conditions. Now, imagine the LHC as a cosmic key, unlocking doors that have been sealed since the dawn of time. When protons collide at energies never before achieved on Earth, they create a brief but intense burst of energy. Some scientists speculate that these collisions could momentarily open tiny windows into these hidden dimensions, like a crack in the fabric of reality. Though these ideas remain speculative and highly theoretical, they raise fascinating questions about the limits of human understanding. Could we be on the verge of uncovering something entirely new, something that challenges our very conception of the universe? Would this open the door to unimaginable discoveries? Or would we be playing with forces that are far beyond our control? Could the power of the LHC inadvertently lead to the creation of black holes, dark matter, or even portals to other dimensions? The possibilities are mind-boggling, and the risks are just as vast. One thing is certain: the future of particle physics is a journey into the unknown, a journey that holds both the promise of new discoveries and the danger of untold consequences. Will we emerge from this voyage with the answers we seek, or will we unleash forces we can neither comprehend nor control? Only time will tell. As we continue to push the limits of knowledge, the experiments at CERN and the Large Hadron Collider raise profound questions about the nature of the universe and our place within it. The LHC's potential to recreate the conditions of the Big Bang, exploring realms of energy and matter that have never been accessed before, is a powerful tool for scientific discovery. Yet, the possibility of unpredictable outcomes lurks in the background, demanding careful attention and rigorous study. Beyond the theoretical risks of black holes and unstable particles, there are other profound implications of the experiments conducted at CERN. One area of great interest is the search for dark matter, an invisible substance that makes up about 27% of the universe. Scientists suspect that dark matter is composed of particles that do not interact with light or ordinary matter in the ways we are accustomed to. The LHC's experiments could, in theory, provide a glimpse into the properties of these elusive particles by recreating the high-energy conditions in which dark matter may have been created during the early universe. The discovery of dark matter would fundamentally change our understanding of the cosmos, but it also poses challenges. For instance, could dark matter somehow interact with our world in ways that are both unpredictable and dangerous? Another equally perplexing and exciting field of exploration is that of dark energy. This mysterious force is responsible for the accelerating expansion of the universe, but its nature remains one of the most profound mysteries in physics. Researchers at CERN hope to unlock the secrets of dark energy by studying how particles interact at extreme energies. If scientists can determine the origins of dark energy, it could potentially lead to breakthroughs in our understanding of the forces that govern the universe. But once again, there is a question of safety. Could understanding dark energy unlock forces so powerful that they might have unintended consequences? On a more philosophical level, the potential for discovering new dimensions or parallel universes through the LHC raises questions about the very nature of reality. String theory, a leading contender for the unified theory of everything, suggests the existence of additional dimensions beyond the familiar four. While these extra dimensions might remain imperceptible to us in our daily lives, the high-energy collisions at the LHC could potentially provide a way to probe these hidden realms. If these dimensions exist and we manage to access them, it could offer an entirely new understanding of the cosmos. Yet, could such access be dangerous? Could it cause us to uncover something far beyond our comprehension? As scientists continue to delve deeper into the microcosm, they also face the ethical implications of their work. The LHC is an incredible achievement, but it is not without its moral dilemmas. What if experiments lead to unforeseen consequences, creating a scenario where humanity inadvertently pushes beyond the boundaries of safe exploration? While many argue that the pursuit of knowledge should be driven by the thirst for understanding, others caution that the risks should not be ignored. The very tools we use to study the universe could hold the potential for profound consequences, some of which might be irreversible. These concerns bring us to the intersection of science and society. As scientific understanding advances, it is crucial for the global community to have an open dialogue about the direction in which we are heading. The research conducted at CERN is not just a scientific endeavor. It is an endeavor that affects us all. From the development of new technologies to the potential for existential risks, the outcomes of particle physics experiments will shape the future of humanity. In this context, it is important that both the scientific community and the public are actively engaged in conversations about the implications of these breakthroughs. One of the greatest challenges scientists face in these explorations is not just understanding the universe's deepest secrets, but also ensuring that their discoveries are used responsibly. The LHC and other particle accelerators could provide humanity with insights into the origins of life, the nature of the universe, and even the very fabric of reality itself. Yet, as we peer into the unknown, we must ask ourselves, what are we truly ready to discover? And are we prepared to handle the consequences of what might lie ahead? In the end, the journey of scientific discovery is both exhilarating and daunting. As we continue to explore the vast mysteries of the cosmos, we do so with the understanding that every breakthrough could uncover new questions, new challenges, and new risks. The LHC may hold the answers to some of the universe's most profound questions, but it also represents a reminder of the delicate balance between knowledge and responsibility. It is a journey that demands both curiosity and caution, as humanity seeks to unlock the secrets of the universe without losing its way.